Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 39, which is a new item type called equation, off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a sample substance, we have an initial mass, we have a decay rate. We need to write the entire function, and we can write anything we want to here. So you see here that we have to know exactly what we're doing if we're going to make this work. So let's slow down here. Let's open up our graph draw feature. Since there's no A, B, C, or D to choose from, let's start from the beginning. We know that if we're dealing with a decay rate, right, that is something that we have learned about in our exponential functions. Okay, so what do we know about exponential functions? Well, the standard form is going to be this right here. Y equals A times B to the x power. All right, so what is that A? Well, that A could be multiple things. So if we're dealing with investment and compound interest, it's going to be your principal. Or you can just say it's your starting or initial amount. If we're dealing with a graph where we had a table, we can actually say it's the y-intercept. It is what happens when x equals 0. Because if you make this x equals 0, you would say y equals A times B to the 0. B to the 0, anything to the 0 is just 1, so y equals A times 1, which means simply y equals A. That's why we can say that A is the y-intercept. It's where the graph would cross the y-axis when x equals 0. So what do we know about this B here? This B is going to be your rate, and it's going to be a decay rate if it is less than 1. It is going to be a growth rate if it is greater than 1. So we're looking for whether it's decaying or growing. And look, they give us the term right there, decay rate. So it needs to be less than 1. And then this x is simply going to be your step. A lot of times we just leave it alone because that's going to be our independent variable. Sometimes it's years, months, days, weeks. In this case, the x is hours. A lot of times it's going to have a time factor, but we're just going to leave it as the x. Okay, so y equals, right? We know that we're going to write the function that way, so we can go ahead and put that in there if we needed to. All right, we can say y equals. Okay. We know we need to do that. Don't worry about putting spaces in between it. Just leave it as y equals. Now, let's figure out the A. The A is your starting amount. Okay? So what are we starting with? A sample of a substance with an initial, look at that, initial means starting. Okay? Because that A is the initial amount or your starting amount. 963 grams. Okay, so A equals, this is A. A equals 963. So in our equation, the A always comes right after the equal sign. Okay, so we're going to put 963. Now, all we got to do is find our B, and we're good to go. Okay, so it is a decay rate, which means it's getting smaller. Now, the whole thing is going to be a 1. Okay, we need to take our 27%. We need to turn it into a decimal, right? So we're going to take the decimal, move it over twice to the left, 0.27. Okay? So if the whole thing is 1, it's decreasing. That means we need to subtract 0.27. And here's the trick, that 0.73, that's your actual decay rate because that's less than 1, but it's not anywhere the problem. So that's the trick here, is we need to do the 0.073. So let's go ahead and get some parentheses, 0.73. And then we're going to do that little exponent right there, hit your x, and that's your answer.